Hey, Algebra 1, so we just started talking about a new section. This is all about inequalities, solving equations and inequalities, and keeping up with certain rules that go with inequalities. Remember, the word inequality really just is the idea of greater than or less than, maybe greater than or equal to, less than or equal to. So let's jump into the homework for tonight. So it talks about a person going on a trip to visit friends, and this person only has $40 worth of food that he plans on spending, along with entertainment. That's kind of how much money he's expecting to spend on food and entertainment together. But of course, he's got to get there, and the price of gas is a variable because he doesn't really talk about how many gallons is needed or how far it is to the destination. And so when we set up part A, write a function to represent the total cost, I set up a cost function based on the number of gallons of gas. So I chose C of G. And we've got our $3.25 per gallon here. And then we also have the fact that he plans on spending $40 on food and entertainment. And so the idea of the gallons is the independent, because he could spend 1 gallon, could buy 2 gallons, could buy 3. But the cost really depends on how many gallons he gets. And so that's how we determine what is the independent and what is the dependent. The rate of change, this is always going to go up in increments of 325 because that's the idea of the variable part. Number of gallons is the independent, and so that is going to be going up by the same increment every time. That 40 is kind of a constant that we're going to live in. And so our y-intercept is 0.40. That assumes that he doesn't really drive at all. He just buys 0 gallons of gas, and he's just going to spend $40 on food and entertainment. So the next part is talking about graphing the function. And so I sketched a little graph here, and because I really wanted to use the entire graph here, I decided I was going to go in increments of 5 on the x-axis, going all the way to 50. And then on the y-axis, I just kept it simple and went in increments of 40, since that was the y-intercept value. So it says, if we're going to graph it, we've got to start with our y-intercept, so that's why I started at 40. And then instead of trying to go up 325 and over 1, I thought, well, let's just go to the very end of the graph and plug in like 50 gallons of gas and see what that costs. And that ended up being 200 and 250. So that allowed me to basically just find another point way down the way, and then I can just draw the graph matching those points, and then it gives me all the other points that I need. So the next part says, what if he'd saved $170 for the trip? Write your answer in words and inequality and determining like how many gallons of gas that would be. So on the part E here in red, I set my inequality to be less than 170 because that's the most money that he can spend on the trip. So when we take off the fact that he's spending $40 on food and entertainment, that only leaves $130 for gasoline. And so when you divide that, that means he can only get up to 40 gallons of gas. He can do less than that, but no more than 40 gallons. So that's what I've circled over here. Tried to estimate where I thought 170 would be. And then I just circled all the other points on the graph that are below that point. So the next part, G, kind of just changes the number. Well, what if you had $220 to spend? So same steps, subtract 40, divide 325 over to 180, and that leaves you with a little over 55 gallons of gas. I believe it wanted us to draw that on a number line. And so I decided, it is less than 55, but you really can't have negative gallons. So I kind of showed a compound inequality here on the number line where X or G, I guess, has to be somewhere between 0 and this 5538. This number is rounded, by the way. So the last part says, well, what if you wanted to spend 92 or more? So let's look at the language in the question that lets me know that. If Chang Ho spent more than $92 on his trip, more than. So that's why I came down here and I decided that instead of using a less than symbol like I did on the other problems, I'm going to make it a greater than symbol. And when you get to the end, if you're going to spend $92, that means you're going to get at least 16 gallons, if not more than that. So we also have another continuation of that idea. So Chang Ho is on his way to visit his friends at a camp, and halfway his destination, he realizes there's a slow leak in one of his tires. He checks the pressure, and it's at 26 psi. but it appears to be losing a little bit every minute. So I know my tires on my truck, they need at least 35 or even 38 depending on what the weather temperature is. And so 26, you're definitely starting to see a little gap in that tire, starting to kind of lip a little bit because you're running out of air. And so as it's leaking 0.1 every minute, eventually you're going to have a problem and you're going to have a blowout. And so we set up a function here, a function based on pressure. So I called it f of p. And I wanted to make this negative because it is losing 1.1 psi every minute. So you really want this to be negative so that as you plug in numbers, you are decreasing from 26. Now, the next question says, well, if you hit 20, if you go below 22, then you're going to have a blowout on your tire. So strictly below 22, I did not use an or equal. It has to be below 22, not at 22, but strictly below that. So I do a few steps here to basically take my function and subtract 26, divide negative 0.1, and a huge rule that you need to keep up with when you're doing questions about inequalities. Anytime you divide or even multiply a negative across an inequality, that sign has to flip in the middle. So that's what you see me doing here. It was a less than at the very beginning, but in this step right here, when you are dividing across that inequality by a negative number, that sign has to flip. And it kind of makes sense with this problem. If you didn't flip it, then saying the pressure had to be less than 40 doesn't really make sense. Or less than 40 minutes doesn't make sense, rather, because the idea is that every minute you are losing 0.1. So after 1 minute, this is at 25.9. And so you're not in trouble yet. It's once more than 40 minutes has gone by, that's when that pressure is going to start to be off a little bit. Even as I'm doing this, I'm kind of realizing that maybe M would have been a better choice because it's a function based on minutes. I know the problem is based on pressure, and that's the concept, but at the very end here, I'm wanting this to reflect an idea about minutes, because that's the idea. How long can you drive before you got problems? And so that would be an idea about minutes, time. Can't spell minutes, apparently. So, just to kind of think about what the variables actually represent there, it makes a lot more sense. Alright, so number 3, we're really just solving each inequality. And again, we're going to try to keep up with that rule of when are you dividing by a negative across that inequality or multiplying. I will be honest, a lot of times it's more common when it's dividing. But if you ever see that, we got to flip the sign. So in the very first one, I am subtracting 13 to the other side. And when you divide by positive 4, that does not change your sign of the inequality in the middle, because you're not dividing by a negative number. Only when you divide by a negative number will that sign change. So part B, we start with distribution. 3 times 4 is 12. 3 times negative 5 is negative 15. And then we start moving like terms around, trying to get everything on each side that is appropriate. But right here in the very last step, you're dividing by a negative. And so what you'll see is that the whole time it was a less than symbol until the very end. I've changed it to a greater than symbol because we divided by negative 23 at the very last step. Let's look at C. C is a good problem to talk about because the best step is to add 5d to the right and then divide 9 back over to get d by itself. But one thing I wanted to show you is if you really wanted to rewrite this, if it was 11 greater than or equal, it's now d less than or equal. So rewriting it, flipping sides, you want to be real careful about following the inequality to make sure that it still represents the same idea. Part D, I'm going to start by adding 6 to the left, adding 9 to the right, and when you divide by positive 9 in the very end, that is not dividing by a negative number, so I do not change the inequality direction. And so that's that section. Alright, so this problem is probably a little harder because it talks about writing a compound inequality. So Crunch Young Company orders its nuts mixed every month by a distributor, and so it talks about how it's $4.50 per pound. but there's also a handling fee of $8.50. And so when I'm trying to build a linear function here, mx plus b, the idea that happens multiple times per pound, you could have more than 1 pound here, that would be your rate of change. So that's why I started with 450b. But anytime you have a fee is b. That's a one-time thing, so it doesn't need a variable there. And so that is my function, or that is my equation for calculating the cost. Now the thing is that it could be anywhere between $100 and $400. So I can't necessarily get 0 or 1,000,000. My outcome has to be trapped between these, and so that's what I did. Similar to domain and range, when you say the x values have to be between two certain values, that's kind of what I've done. This price has to fall right between 100 and 400. So now I start solving it just like a normal equation or inequality. But now that you have two sides, you really have to go to both sides to work your way out of the middle. So I subtract 850 to both sides, and then in the next step, I divide 450 to both sides, and ultimately you're saying that you can order anywhere between 20.3 pounds and 87 pounds, and that would result in a final price of somewhere between 100 and 400. Last section is all about average rate of change. So I want you to calculate the slope between these 2 points here. And then on the second one, really took a second to basically study all of my rate of change. The right side kind of changed a little bit, the left side as well, but they changed significantly similar. And so if you were dividing the rate of change here doing the slope formula, they're all giving you -1/2. And luckily they give you the y-intercept in the table, and that can help me go ahead and tell me what the back number is in the equation. Good luck, and I'll see you tomorrow.